Good morning, and thank you for joining us for today's webinar. The topic will be ASC's 61850 SCL Manager, and the uh, main discussion will be centered around configuration reuse with templates and comparison of IED configurations. Your host today will be Starin Joes. He has 21 years of experience and is the Director of Engineering and Operations. Starin is an expert in IEC 61850, substation configuration language, along with substation protocols, and is one of our trainers for IEC 61850 protocol and our ASC 61850 test set. A bit about Applied Systems Engineering Incorporated is we are a leading RTU manufacturer, and we sell RTU and IED test sets across the globe. We support testing of legacy protocols such as your bit protocols in SCD environments, CDC, Conatel, etc., as well as the newer standardized protocol like DMP3, IEEE 2030.5, along with IEC 61850 that have been adapted and are now in play in the substation environments. ASE has been around since 1988, and we became a part of the Calcatech umbrella in 2015. ASC's 61850 SCL Manager is a substation configuration tool. This tool allows you to design and configure 61850 solutions from the top down, bottom up using vendor files and inputs. And we support the use of Bay templates, which will allow for configuration and design and gives you the ability to rapidly reapply that configuration as you scale up. The tool supports interoperability between the 61850 edition 1, 2, and 2.1 IEDs in your projects. We have some validation features as well that will confirm version information. And the main focus of our webinar, again, is for configuration and reuse of that configuration design across different IEDs in your applications. We have a August 2025 release that just came out, which we're highlighting today. And then we have some other features we'll talk about within the tool itself. A very handy feature is our signal matrix, which actually shows you goose mapping, reports, sampled values, and it easily provides an overview of how those signals are configured between subscribers and publishers and devices within that configuration. We can design the substation specification in a virtual fashion or offline fashion, and we can also incorporate actual IEDs into that configuration. So you can not only virtualize the configuration, but later deploy that with real IEDs with new inputs. And I'll turn that over to you, Starin.
Yeah, hi. Thanks, Larry, for the detailed introduction on the topic and the tool. As Larry said, we will be focusing on the use cases around the Bay configuration today. This has been a big topic of discussion, right? How we can reduce the time, engineering time for a 650 substation, because most of the utilities across the globe generally use a pattern while engineering their systems. The protection schemes or the general Bay configuration or Bay design will follow a pattern. Each utility may have their own philosophies to create the Bay configurations, but once these are standardized across the system, there is a tendency to kind of reuse most of it over and over again for the new substations, and that's where the reuse of configuration will be useful. So once you design the signals and identify the mapping of signals between the devices, then it's just a matter of replicating that configuration across multiple bays, and that will drastically reduce your engineering time. In the previous versions of SCL Manager, we were focusing on the SLD as a template. That means you need to draw the single line diagram, and if you have a default way, you can kind of save it as a SLD in SCL Manager, and you could kind of replicate that way SLD over and over again. But the IED was not included as part of that template in our earlier releases. So in the new release, what we are focusing is to extend that bay configuration with IED configurations as well. So that way you get a complete package. So when you save the bay configuration, you can get both the single line diagram part of it as well as the IED configuration part of it. It will even save the signal exchanges between the IEDs within that bay. So that way, when you import the bay configuration, it basically gives you everything that was configured within that bay. So that's the primary use case we will focus on. We will create a new bay configuration as a template. Then we will look at the use case where this bay configuration can be reused while creating a new substation configuration. So that's the first part of the webinar. And we will also see how we can compare the IED configurations within or between bays. So this is another feature in our tool where we can match the signal list between the devices and find out how different we are with respect to the IED configurations. So in part of the demonstration, we will also see how the signals are mapped between the devices. So while creating the bay configuration itself, we will be able to see the signal metrics. Signal metric is a very useful tool where you can see the transactions between the devices, and it will give you a bird's eye view of the entire system. Further, you will also see how the goose mapping and sample value mappings are done, and we can also look at the network addressing options. So as Larry said earlier, SCL engineering is part of the 61850 ecosystem. Definitely you cannot do much without the SCL engineering in any digital 61850 digital substation, right? So we'll focus on the SCL engineering and SCL configuration part today. So our other products includes the test set. Test set is a troubleshooting tool where you can act like a client to look at the devices. You can scan the devices in the network. You can monitor the traffic from the network, and you can also simulate the devices in test set. So test set is more like a all-purpose tool that can do a lot of things for your troubleshooting and simulation and testing use cases. And recently we added the BNet hardware into our offering. BNet is a hardware accessory that works with testset, and it allows you to monitor sample value traffic and even simulate the sample value traffic. So recent version of IEC61850 testset, we have added the fault simulation capability and PTP master capability. So you can test your relay for basic functions without any other hardware. So I'll not talk a lot about the other tools. We'll focus on the SCL tool in this webinar. Okay, so first I will talk about the signal transactions that we are planning within a bay. So here in the configuration that we are planning to create, we are planning to have a few devices. So one is the line process interface unit, where we will kind of have the sampled value streams generated. So this protection or process interface unit will be connected to the CTPTs and measure the voltages and currents. And that information will be sent out to the network. And further, there will be a line protection unit in the network which will receive these sampled value streams. So we'll see that sampled value streams are kind of transferred from the LPAU to the LPU. We can see this in the signal metrics, and this also will go to the BCU, bay controller unit in the network. So these two devices will be monitoring the sampled value signals from the network, and based on the scenario, like if there is a fault in the network or if there is a disturbance in the network, the LPU will monitor that situation and trip the breaker. So tripping of the breaker uh, will be initiated by the LPU, and you can see this amber colored arrow that indicates the goose. So that will go to the LPAU. LPAU also is kind of also acting like a switch controller, where it has got digital outputs to actuate the breaker controller. So it will trip the breaker, and you will be able to see the response in terms of goose. So as soon as the LPAU trips the breaker, it sends the status of the breaker as a goose packet, and that can be monitored from the BCU. So you can see that BCU is monitoring all these transactions. It will monitor the sample value streams. It will look at the goose trip signals from the LPU. And also, it will look at the goose status of the breaker from the LPU. And based on that, it can send out reports to the HMI. So this is the general scheme that we are trying to simulate or create in the bay configuration, and we can see how we can replicate this configuration for multiple bays. Let us proceed with the demonstration part. So I'll start SCL Manager to demonstrate this use case. So I'm starting the tool. It is okay. So those who are not familiar with SCL Manager tool, it is a full SCT. By SCT, I generally mean the full capable substation configuration tool. It can also act like a substation specification tool. So let me copy this folder and create a project. So I have selected the location, and so I'll name it as a bay template project. So when you create a project, you will get a SLD toolbox. This is part of the substation specification capability of the tool, where you can draw the single line diagram. And if you look at the workspace, you will see we can add multiple projects here. And here you will see the SCD file that is automatically generated as part of your SCL engineering process. And then you have the single line diagram here, you have the network diagram, and also you have the IEDs. So during today's demonstration, we will focus on the single line diagram part and the IED sections. So we'll create a single line diagram. We can create a new single line diagram and draw the single line fresh, so that is possible. And since we don't have a lot of time during this webinar, we will try to use one of these templates. So I'll use this single bus scheme that is preloaded in the SCL Manager. There are several options available. These are general or frequently used schemes. In a substation, if you have your own scheme, you can create the template in a SCL Manager. And once the template is created, you can save it as an SLD template. So now I will proceed with this single line diagram. So this is a single bus scheme that I have identified. So imagine you have this identified and you want to create a bay template out of it. So we'll pick one bay from this configuration, and you can see that most of the other bays are exact replica of the first bay, right? So this is the use case that we are trying to address. So if you configure one bay, how can you reuse this configuration over and over and reduce the engineering time? So to create the template, I will remove all other bays. As I said, in your use case, you will be able to create a fresh configuration and just saving some time in terms of creating this single line diagram here. So if you look at the blue arrow here, you can see which all logical nodes are assigned to each of these functions. So here, if you browse through all these, right, there are two isolators or disconnectors, and then you also have a circuit breaker here, and you have a line going out, right? So these are the logical nodes available in this bay. And we can add the logical functions as you need. So here we can see that there are no CTPT diagrams available here. So to indicate CTPTs for this bay, I will add the logical nodes for those. So I'll create TCTR. So typically we will have at least 3 TCTR and TVTRs to indicate the currents and voltages. So we'll go ahead and add those. Normally you will see these CTPTs as part of your drawing. Since we don't have that, we'll add it under bay. So the entire 61850 logical node set is available for you here. So you can see that I'm adding it from the superset of all logical nodes. Okay, so I have added 3 currents and 3 voltages to indicate the phase ABC currents and voltages. And if you are interested to add additional logical nodes, you can do that. You can look at the different subgroups here, like automatic control, supervisory control. You can see the entire list of logical nodes under substation profile. And if you browse further, you can see the logical nodes available under facts profile. Then we also have the DER profile logical nodes here. Then we have hydro logical nodes, and finally the wind related logical nodes. So 61850, the entire 61850 logical node profiles are already preloaded with the SCL manager. So it helps you to create a new configuration or a virtual configuration for a substation or even for the other domains. So now we have a base drawing for a bay. I will rename this bay as bay template. Yeah, so I have assigned a name here. So as you create the single line diagram, you can see that the corresponding SLD or SCD elements are automatically added. So it will help you to kind of see what's going on with respect to the SCD or SCL file. So at this point, we have the TCTR and TVTRs added under bay section, and then rest of the logical nodes are available under the respective equipments, a disconnector, circuit breaker, and isolator. Now let us pick the IED configuration for this profile. So here you will be able to import the ICD files from different manufacturer files. Like if you have certain ICD files identified for this use case, then you can go ahead and import those. SCL Manager allows you to import the files from a folder or uh, from SCD. You can pick the configuration from anywhere. So for this webinar, I will pick the configuration from a already created SCD file. So let me change the filter. So we support all these profiles like ICD file, IID file, CAD file. So you can import IED configurations from any of these profiles. In this case, I'll use a pre-created configuration as part of the 2024 interoperability workshop. So I'll use that configuration and try to load it from there. Okay, so you can see that there are certain devices already available as part of this ID configuration file. So you can see that there is a PAU, there is a bus merging unit, transformer protection unit, HMI, monitoring device. Then we also have another PAU, transformer PAU for high voltage, and another monitoring device. Then we have disconnector, switch controller, clock, LPU, and BCU. So for this use case, we will try to create the configuration using 3 of these devices. And here you can see that this LPAU has some SCL validation error. So we can look at that error before we proceed. So let us look at that configuration. Okay, so this tool is capable of identifying the errors in the SCL. So here, based on this configuration, this device has identified itself as a 2007B device. But since we imported it from SCD, it has got certain attributes of edition 2.1 or B4. So that's why it's complaining that these attributes are not allowed if the IED claim it as a 2007B schema. So we know that it's not a major issue because we already know that this is an SCD file and uh, these errors are okay if we look at from a SCD perspective. Even though the device doesn't support 2001, the old profile or project will be able to support 2.1. So we should be okay with this error. So yeah, tool will notify you if it is, especially if it is an ICD file, you should not be seeing this error. So you, on case-to-case basis, you can find out whether the error is okay to proceed, or if you need something to be fixed in the manufacturer ICD file or CAD file, you can contact the OEM and get that addressed before importing into the tool. So now let us proceed with the force import. So force import allow you to add it to the project, otherwise it will not allow you to add the configuration to the project. So I'll remove all the devices from the selection. I'll proceed with LPAU and LPU and BCU. So as discussed earlier, we will focus on these transactions, using these 3 devices. You can have bigger bay configurations as part of your standard template. Only thing is that in this webinar, we will focus on these 3. Okay, let us proceed with the import. So now we can see that this device is edition 2.0 and these devices are edition 2.1. And once you add the devices or IEDs into the configuration, you may start assigning these uh, devices into respective logical nodes. So you can see that here LPAU supports TCTR, so you will be able to link it with that. And using this method, you can link all the logical nodes in the single line diagram against these logical nodes in the IED. So if by this you are saying that this function, TCTR functions and TBTR functions will be handled by the LPIU device in the network. So now we have mapped all the current transformer and voltage transformer signals, and now we'll proceed with the switch functions. So I will add the disconnector switch function to the LPU. LPU stands for line protection unit. And CALO is basically an interlocking function, which you will typically see in a BCU. So we'll add it to the BCU. And supervisory switch controlling function typically is accessed by access to the BCU. So we'll add it there. I'll follow the same convention for other disconnector as well. So this is the disconnector 2. And this is the next disconnect interlocking, and here we have the supervisory control. And the circuit breaker function will be handled by the protection unit. So we'll map it to the circuit breaker, and again we'll continue with the breaker. We will add the breaker interlocking to the LPU, and then let us, for this one I will add it to the LPU. Okay, so this is a high level, function, and definitely that tripping function will be handled at the LPU. So you can see that using this, you don't have to really follow this convention. Based on your protection scheme, you can allocate the logical functions that are required in each of these equipments, and you will be able to create a template based on that. So from I'll reduce the size of this diagram a little bit. Okay, so now we can see that we have the bare template available here. Now let us proceed. What we have done is we have mapped the single line diagram logical nodes to the actual logical nodes in the devices. So instead of this, you may create the virtual IEDs. So if you want to use this as a specification with the IED names, logical device name, reports, goose, etc., then you may create virtual IEDs instead of using an actual device. And later you may replace that virtual device with a real device. So that use case also is supported in the SCL manager. For this use case, we will create a configuration with actual devices so that you can reuse this configuration over and over again. So let us proceed to the LPIU and look at the sampled value streams. So you can see that these sample value streams, it has got multiple configurations, and we'll be focusing on the one with sampling rate 4800 and the one with the number of ASDUs 2. So if you look at the destination of these signals, you can see that this signal is going into the line protection unit. So this sampled value stream from LPIU is going into the LPU protection device, and also it is let's see whether it is mapped to any BCU. So we can find out this, find details instead of looking at here. You can see that if you go to the external signal, you can find out how the mapping is done. So here you can see that this LPIU is sending out currents and voltages, and that is going to LPU. We have already seen this configuration. And in addition to that, it is also going to the S1 logical device, phase A, S1 LLN0. If you browse to that logical device, then we should be able to see that here. So you can see that here this signal is mapped. So this is a pre-created file. Since we don't have a lot of time to demonstrate this mapping, you can basically drag and drop the mappings from dataset here to here, so that will allow you to create the mappings. So yeah, here you can see how these signals are mapped. So we already have the mappings created from the LPAU sampled value stream to the LPU and to the VCU. So this way you can create the sampled value mapping. And if you go further to the LPU where the goose is generated, you can see that this is the protection and reclosure goose that is available in LPU. And if you browse to the LPAU as a destination device, for example, you can again look at this configuration in the xref. You can filter the signal metrics based on the goose, and it will tell you to where these signals are mapped. So you can see that this signal, the trip signal, for example, this is the trip signal, trip PTRC, and it is mapped to the specific logical node in the LPAU. So if you browse to that specific logical device, you'll be able to see those signals. So you can see that here we are looking at these signals, right? You can see that LPU signals are mapped to these goose inputs. And if you browse to the details, like further, you can see that the goose from the LPAU, this is the position of the breaker. And if you go and look at the xref, you can see that the goose signal from the LPAU, which sends out the position of the circuit breaker, it is actually going to LPU and VCU. So these are the logical devices that are accepting these signals. So we can look at this logical device CFG in LPU to look at the signal, and here you can see the other signal as well. So let us look at the LPU, and in CFG you can see that this is the signal that is receiving the circuit breaker status. And if you browse to the LP VCU, you will be able to see the breaker status going into a specific input. So it's a matter of just drag and dropping these operations from this dataset variable to here. So yeah, I can demonstrate one such scenario here. So for example, here I can pick another goose signal and drop it to, okay. So there is a check that validates the source signal. So here, since we were trying to map it from a circuit breaker, it is not accepting it. So we'll have to find a matching signal that can accept this message. So it looks like we don't have any here. But let us look at the other signals available. Okay, I think I can pick one signal from LPU. Yeah, here we have the op close, RREC op close. We'll find out whether any signals are supported in VCU to accept that. Oh, looks like it is only accepting the trip signals. Okay, so here you can see that there is no restriction on mapping the signal. So here, if the device is providing xrefs with the predefined logical node, data object, and data attribute, the tool will not allow you to map or violate those rules. But in this case, this device is allowing to map any signal. For example, here we can look for the RREC signal, and we should be able to map. See. So yeah, here we have we need to look at the op close. Yeah, here we have the op close signal. I think it's already mapped. So for the demonstration purpose, I will remove this mapping and recreate it. So you can see that this mapping is gone. All you have to do is just drag and drop this mapping here. So that will allow you to kind of create this mapping. So it's a pretty straightforward to create a mapping, goose or sample value mapping from a device to the destination device. So we have seen the goose transactions, and to visualize this at a high level, you can see that signal metrics here. So here you have several options to filter. You can filter it based on the device. For example, say imagine you want to see all the signals going out from LPAU. So then you can select that device in the source, and in the destination you can select all. Then you will see which all signals are going out from the device. You can see that here we have the sample value messages going out, and further you can see the goose messages going out. You will also see the destinations here. And the other way, you can also select the signals from LPU. You can see that LPU signals are only going to LPAU for trip and reclosure functions. And if you want to see the signals going from BCU, you can also do that. This is mainly, for the supervisory control of the switch. If a user want to operate the breaker, then you can use this BCU option. So yeah, this view allows you to view all the signals corresponding to that selection. And you can also export the signal metrics that you are viewing to a CSV file here. And from a networking perspective, you can see how the network looks like. So for example, here you can see the subnetworks assigned for all these devices, and you can set the IP addresses, and you may also look at the you know uh, the other parameters like goose. You will see the schema version of all these devices here, and you will see the physical connection and other properties here. The gateway, so entire IP address configuration can be configured here. And further, you can look at the goose communication details. You can see how the devices are managing the goose packets. You can see the MAC addresses for those goose packets. These are multicast MAC addresses for these goose signals, right? And you can also look at the sample values. And if there's any report configured, you can look at those as well. But at a high level, all the networking related configuration can be browsed from this network configuration or network addressing pane, and you can kind of manage all this configuration here. So once you create the configuration, you can do a quick validation, and I will see what is the error in this configuration file. Okay, so here we can see that this logical node. So as per the schema constraint, we should not be having any parameters with a null or blank. So it looks like this mapping was not done properly. So we'll have to remove this mapping to validate this further. So we can see that it is under, so this signal has been mapped under, let me see where the signal is appearing here. This is an extra where it is accepting signals, and looks like this is an LPIU. I'll confirm that. So this is an easy way to identify whether the file contains any errors. So here, right, you can see that this is a logical device. We are looking for the IED. So MXU. There are two ways to fix these errors. You can either manually fix it in the file. Tool allows you to manage this uh, manual changes. So now we don't have a lot of time. We can go ahead and correct this error manually. So let us, yeah, we can look at this file here. There's an option in the tool where you can open the SCL editor, internal SCL editor of the file. And further, yeah, you can look at this error. So here, this it is complaining that LN instance is invalid. So we'll just remove that, and we validate the file. And we go to the next error. We have the same error here. There is a blank LN instance. We'll validate that. And further, we have the null configurations for these terminals. The null value is not allowed. So we'll remove these null objects. I think this is because this terminal is not connected to any. Yeah, this is where you have a problem when you create the base templates. So you need the terminal on one side to be open so that you can connect to other devices, right? So in a real use case, also this might happen that you need to keep some of these terminals open so that you can connect to other lines in the system. So I think this error is okay because you want to, or you should keep this terminal open for future connections. So it looks like we are okay with this file now, and I will save this configuration. Yeah, disk warning that there is an error in this file, but you can continue. So if you are already known with this error, you can proceed. And at this point, you will be saving this. So you have validated the file, right? You have and the validation and oh yeah, I think I'll have to save this project once again. Um, Once the validation is done, you can save it as a template. So you will use the export by template option here, and I will save it as a okay. So this is the custom file extension where you will be able to create the by template. And you will be able to edit the descriptions of these extras. So these, it's warning you that these are some specific descriptions that you have for this configuration, whether you want to make it generic. But yeah, in a real scenario, you may make it generic, but in this, for this demonstration, I will proceed. Okay, so now I have saved the bay template. You can see that the bay template is saved here as a file. Now let us see how to reuse this in a new project. So for that, I will create a new instance. project instance in SCL Manager. Let me open the tool. Okay. I'll create a new project and I'll browse to the same location here so that I have control of the location where the project is saved. And further, we can name the project. So you can give your configuration name here. Then you will have to create a new substation configuration, right? So here the use case will be that you will have an actual substation, a voltage level. Now at this point, your interest will be to import the bay template. So you already have the template created in your system. Now we'll try to import that into the configuration. So we'll try to browse to the bay template. So this is the bay template that we have created just now. Let us import that. So here it will allow you to instantiate this bay template multiple times if required. So yeah, in a typical scenario, if you want to create it only once, you can specify it here. But if you want to create more instances, you'll be able to do that. And it will also allow you to set the names for these bays. So I'm assigning some default names for these bays. And here you can see that this devices are assigned with this instances. I'll assign some instance names. You can make these changes as you like. So if you have any prefix to be assigned to these devices, you can do that. So the tool, what it does is it will keep the mappings exactly as is. So basically, all the extra configurations will be replicated based on your IED names. So you don't have to really do anything. So here you can see that we will import the configurations. So it's creating the single line diagram based on the imported bay template. And you can see that it is creating the IEDs in the configuration automatically. So you can see that it's automatically creating all these bay templates. Now you can see that these bay templates are created. And if you browse to the individual mappings, you can see that these mappings are created with the respective device names. So here LPIU1 is the instance for this bay, and all these devices are created with that instance name. And if you browse further, you will see that the current transformer and voltage transformer signal are assigned to LPIU2. So if you have same make of devices, then you can simply instantiate those devices as you like. So these are all from the instance 2 of these devices. Then now you have the instance 3. So one thing you need to resolve is the network addressing part of it. Tool will not generate the IP addresses automatically, so that you will have to handle separately. So you can see that these devices, these IP addresses are replicated, but if you try to save this IP addresses again, it will complain that there are duplicate IPs. So yeah, you will be able to identify these errors in the network configuration and resolve that later. And here also you can see that these ghost messages were created with these so that there are some errors. You can see that there are duplicates here, and sampled value messages are also duplicated. So you'll have to resolve that before proceeding with this configuration. But otherwise, all these signals are kind of imported correctly and instantiated correctly. So here, if you look at the signals, for example, right, you can select the signals that you are interested in. So if you are interested in Bay1 signals, then you can uh, select the Bay1 configuration. You can see that it is exactly matching the previously created configuration. It's all in the instance one of these devices. It's going to respective instances. And further, if you select the other set of devices, you will see something similar for instance two. So as you select the devices, it will populate the signals, the signal metrics. If you want to analyze the signals in detail, you may export it and use a CSV parser to analyze the information. So this will allow you to create the templates and reuse that templates over and over again. Like here, you have created the entire configuration, right? And the corresponding SCD also will be populated. So if you remember, we have kept this terminals open. So that will cause a problem in the real configuration. So to avoid that, you might have to create a line. In a real scenario, you will have two voltage levels. To avoid the error, we can have the electrical line and connections to that line. So that way you are not really no, I think I need to use a different type of line for this connection. I need to use a connectivity node. So I'll use a horizontal connectivity node to handle this. And further, you can close the connections. So I'll make the connections from these terminals. Okay, I think we have closed the connections. So it's not an open connection anymore. And if you validate, we should not be seeing this error. Yeah, we don't see that open terminal error anymore, right? So that means, so yeah, we should have cleaned these errors while saving the Bay template. These errors are repeating from the other one. But the other open terminal error has gone after import. If you did not have this configuration, then it will be giving you that open terminal error. So you can see that this error is present here, right? So I was referring to this one. So yeah, this way you can create the configuration and it will allow you to manage the configuration as you like. You can replicate this configuration over and over again. Right now, we only support Bay templates. So if you have a similar base in your configuration, you will be able to replicate that over and over again. That summarizes our webinar topic. I think we have covered all the points, right? Oh, the last point we wanted to do is the comparing of the devices. So here you may set one device as a reference device and compare other devices against that reference. So it will analyze all the logical nodes in that IED and find out whether there is any mismatch. So in this case, you can see that it is a perfect match because we have instantiated the same IED multiple times, right? But if you are interested to match one device against other, you will ideally do it in the case of for similar devices. But right now I am doing a comparison of Bay controller unit versus protection unit. So you can see that model compatibility is very less. It's almost like 11%. This will not be the case if it is a way controller versus way controller, or a protection unit versus protection unit. Using this method, you can find out whether the models are exactly matching with the devices. So this will be handy if you are kind of replacing one manufacturer IED with another manufacturer IED. You can match, you can import the file into the project. You can actually create another project and import that ICD file and then match it between the project. So that way you will be able to easily compare and identify whether the logical nodes or models are similar between these devices. So here you can see that it's exactly matching, but for other cases you can find out the errors. Yeah. So that summarizes the details at a high level. This is what we wanted to cover. Now we can proceed with the questions. So the first question is, can you come back and instantiate additional copies later or just once? So yeah, if you want to instantiate additional logical nodes, what you will do is you can do this again, like you can follow the same process again, import the bay templates once again, right? And you'll be able to do that. So here you can specify if you want the fourth instance, you can come back to this configuration and import. So tool will automatically create that for you. So that was the first question. And so yeah, it is exactly same as this one. Okay? You can create it here. Everything will be matching based on the instance numbers. And the next question is, yeah, will this presentation and recording be available? Yes, it will be sent to all the webinar registries, so you will be receiving the recording of this webinar. The next question I see is that, can I import this SLD from another IEC configurator, or do I have to create this from this tool only? So here the coordinate information is a bit tricky to reproduce if you import it from a different tool. So we generally follow a algorithm where the tool will look for the coordinates. So here, if you browse to this SCL file, right, you can see that there are certain coordinate information associated with all these elements. So you can see that this XY coordinate for this bay is 3 and 2, and you have the same for voltage level and for the substation. So all these elements are kept at certain locations within this profile. So if the other tool is following a different scaling or different convention in generating this coordinates, then you might see that the placement of the SLD is different. You will be able to specify that when you import the bay. For example, here it is asking you where to place the. Yeah, I think if you specify multiple, then I think it will ask you to. Yeah. So there is an option to specify where you want to keep these bay instances, whether it is horizontally or vertically. So you will be able to do that. But again, within that SLD configuration, if the other tool is maintaining a different type of scaling, then you might see some problem in the coordinates. But you can always adjust it. You can kind of, once you import, you can always play around with the single line diagram and adjust the position of the location. Yeah, I think we have several questions on the recording of the webinar. I see at least 3 or 4 queries on the availability of this recording. So yeah, to answer that question again, we will have this recording shared with everyone who has registered for the webinar. Looks like, yeah, we are at the end of the session. Yeah, if there is any other questions, you can always reach out to us and we will be happy to clarify the details. So Larry, maybe we can wind up the webinar, right? Looks like we have covered all the points in this webinar.
Yes. Thank you all for your participation today.
Okay, thanks.